Okay, alright guys, so today we're going to write a quadratic function in vertex form given the following information. A line of symmetry, a point, another point, and an opening. So I'm going to start by writing our vertex form of a quadratic function, which is, here we go, f of x equals a times x minus h squared plus k. So given what I was given, the very first thing I see that I can plug in is my line of symmetry, because I know the line of symmetry is going to be the x equals h. So I'm going to plug in 3 for my h here. And everything else just drops down. So I get f of x equals a parentheses x minus 3 squared plus k. So I use my first bit of information, so I'm going to go ahead and check that off. Now I see I was given 2 points and an opening. I know that the opening being up means that my a value at the end has to be positive, but here I see that I have 2 points and I'm going to use those first. Each of these points is an f of x pair or xy pair. It's the same thing, but I only have one x and one f of x in this equation. So what I'm going to do is I'm going to go ahead and create 2 equations that I can plug those into. So I get f of x equals, I'm just rewriting this right here, a times x minus 3 squared plus k. And then I'm going to write this one, f of x equals a times x minus 3 squared plus k. So I'm going to take this first point that I highlighted or colored here in green, and I'm going to plug it in for x and f of x. So this is 9 and 1, and everything else just comes down. So I get 9 equals a parentheses 1 minus 3 squared plus k. And then I'm going to do the same thing for my second point here. This is going to be x and f of x. So the 3 is going to go in for my f of x, and the 4 is going to go in for my x. And everything else just drops down. So I get 3 equals a parentheses 4 minus 3 squared plus k. Okay, so now these equations are looking a little messy, so I'm just going to clean them up by simplifying, and the first thing I'm going to do is simplify the parentheses. So I get 9 equals a parentheses 1 minus 3 is negative 2 squared plus k, and then I'm going to do the negative 2 squared, which is negative 2 times negative 2, and that leaves me with a positive 4a plus k. And I'm going to do the same thing over here. So here the 3 comes down, the a comes down, 4 minus 3 is 1. So I have 1 squared plus k, and then 1 squared is 1 times 1, which is 1, and then 1 times a is just a. So I get 3 equals a plus k. So at this point we have a system of equations that you learn in Algebra 1, and then there's quite a few ways to solve a system. You can do that by elimination or substitution, but what we've been working on lately is graphing, and we're going to graph those to find the point of intersection to solve this system. And we're going to use our calculator, our graphing calculator, to do that. But our graphing calculator doesn't graph in a and k, it graphs in x and y. So I'm going to go ahead and change my a and k to an x and y. So I get a equals x and k equals y. So I'm just going to substitute in or change my variables. So I get 9 equals 4x plus y, and here 3 equals x plus y. Okay, so now that I have this, I'm going to graph this system in my calculator and solve the system in my calculator by finding the point of intersection. So that's what I'm going to do next. So let me show you that. Let me just finish my little note here. Okay, here we go. So what I'm going to do is I'm going to get a new graphing document. Now, how the calculator is set up is that they're in function notation, f of x, and our 2 equations here are not in function notation. So you could solve these for y to put them in your calculator, but I'm just going to take a little shortcut, and I'm going to change my graph entry edit to relation so I can plug them in just as they are. So my first equation is 9 equals 4x plus y. So let's go ahead and get that plugged in. So I get 9 equals 4x plus y. Graph that. And let's go ahead and graph the second one, which was 3 equals x plus y. So 3 equals x plus y. And next I want to tell the calculator to find this point of intersection for me, because that's the solution to our system. So I go to menu, analyze graph, in intersection you kind of got to give it a hug. You go to the left and right of it, and there it pops up as 2, 1. So let me get this big. So our calculator just told us that the solution to the system we had created was 2, 1, which we know is an xy point, but we are not dealing with x and y here, we're dealing with a and k. So really x is our a value and y is our k value, which was what we were missing in this equation here. So we're going to plug in, for our a, we're going to plug in a 2, and for our k, we're going to plug in this 1, and we're going to rewrite this as f of x equals 2 parentheses x minus 3 squared plus 1. And there is my quadratic function in vertex form. I've went ahead and found it, given that information. Now, if you want to check this to make sure that it matches up with this information, you can just go ahead and graph this in your calculator and verify that it on the table or from the graph that it goes through these points, and that the vertex or the line of symmetry is at x equals 3 and the opening is up. Oh, by the way, we got a positive a value. So if we have a positive a value, this last clue or this last information is true as well. All right, so there you go. That's how you write a quadratic, or one way you can write a quadratic function in vertex form given that information.